The class 10 mathematics NCERT extra question. It's from the chapter circles. It's quite a hard question, very interesting one. PQ is a chord of length 24 centimeters to a circle whose radius is 13 centimeters. Tangents at P and Q intersect at T. If O is the center of the circle, we need to compute two things. We need to compute the length of PT and the length of OT. Let's start by describing the circle. O is the center of the circle. This is the circle we are talking about. Let's draw a chord whose length is 24 units. Let the chord be PQ. From P and Q, we're going to be drawing two tangents such that they intersect at point T. Now, let's connect the two radii, OP and OQ. We have done whatever is available right now. I'm going to be establishing few things with the two triangles that we have drawn. The first triangle is triangle PTQ. PTQ is an isosceles triangle. Why? Because TP and TQ are two tangents drawn from an external point. These two will be equal in length. So PTQ is an isosceles triangle. I'm going to be doing one thing to this triangle. I'm going to be bisecting angle PTQ. I'm going to be drawing an angle bisector for PTQ. Let's say it starts from T and meets the opposite side PQ at point R. This is where it meets. I'm going to be establishing few things with the two triangles that we have got right now. We had a PTQ. We have broken it down into a PRT and a QRT. So I'm going to be looking at both these triangles, triangle PRT and triangle QRT. In both these triangles, first thing we have established is TP is equal to TQ. So one of the sides of each of these triangles is the same. TR is a common side, so that is also same. So we established a second side which is same. TR is a bisector of angle PTQ, which means it's going to break this angle into two equal halves. This is a theta, this is also a theta. So what have we got? We got two sides, PT and TR, same as two sides, QT and TR. And the angle included, which is PTR and QTR, being the same. So by SAS, we can establish that PRT and QRT are congruent triangles. If we establish their congruent triangles, we can quickly establish two more things. One, the corresponding sides PR and RQ will be equal. If PR is equal to RQ, then what do we have about R? R is nothing but the midpoint of PQ. If R is a midpoint of PQ, PQ measures 12 centimeters. PR is going to be equal to 12 and RQ is going to be equal to 12. So establish that R is the midpoint of PQ. Next thing we are going to be establishing is corresponding angles QRT and PRT are equal. They add up to a 180 degrees because angle in a straight line is 180. If they're equal and they add up to 180, then this angle is going to be equal to 90 degrees. So we establish that angle PRT is 90 degrees. We establish that R is a midpoint of PQ. Right? This much is done. I'm going to repeat the same exercise with the second triangle POQ. Why is it isosceles? OP and OQ are radii to the circle, which means triangle POQ is going to be isosceles. So the bisector of angle POQ is going to do exactly the same things that the bisector of angle PTQ did. It's going to meet PQ at R, which is a midpoint of PQ, and it is going to be meeting it at right angles. So a couple of things we can establish. OT is one single line that passes through R. OT is perpendicular to PQ, established. Second point is R is the midpoint of PQ. So establish these two things. Quickly summarize it in a printed form before we move on to the next step. We are drawing a bisector to angle PTQ, meets it at R. By SAS, PRT and QRT are congruent triangles. Therefore, R is the midpoint of PQ and angle PRT is equal to 90 degrees. Going to run through the same exercise with triangle POQ, which is also an isosceles triangle. The bisector of angle POQ will meet PQ at R, which is the midpoint of PQ, and will meet it at right angles, which means OT, a single line passing through R, is perpendicular to PQ and passes through the midpoint of PQ. Done. So much is done. The next step I'm going to be doing is computing the value of OR. Let's write down whatever we know. We know the radius of the circle, which is OP, is 13. We just established that R is a midpoint and PQ equals 24. So PR will be equal to 12. Now, what is going to be the measure of OR? OR is equal to under root of OP square, which is the square of the hypotenuse, minus PR square, Pythagoras theorem. OP is a 13, so 13 square, minus PR is a 12, so PR square is a 12 square. Under root of 13 square minus 12 square is our answer, which is under root of 169 minus 144, which is equal to root 25. So the value of OR is equal to 5. So computed this value to be equal to 5. Quickly summarize this also in a printed form before we move on to the next step. Right? OR square is equal to OP square minus PR square, which is 169 minus 144, which is equal to 25. So the value of OR equals 5. Now I'm going to be looking at two triangles and I'm going to be establishing. We did congruence establishment in the last slide. In this slide, the next one, we're going to be establishing similarity between two triangles. Which two triangles? We are going to look at triangle ORP and triangle PRT. How is it similar? By AAA. Let's take a minute and do it slowly and then proceed further. Angle ORP and angle PRT are 90 degrees. So these two angles are 90 degrees to those two triangles. Let's assign this value, this angle POR, to be equal to theta. One angle is 90, one angle is theta. So angle OPR, this balance is going to be equal to 90 minus theta. Now OP is radius to the circle. PT is tangent to this at the point P. So this angle OPT, place where the radius and the tangent meets, is always going to be a right angle, which is equal to 90 degrees. OPT is 90. We said OPR is 90 minus theta. So this should be the balance. This is going to be equal to theta. So angle RPT is equal to theta. Angle PRT is equal to 90 degrees. So what can be this angle? This is 90, this is 90, this is theta. So this should be equal to 90 minus theta. So in triangle PRT, what are the angles? Theta, 90, 90 minus theta. In triangle ORP, what are the three angles? Theta, 90, 90 minus theta. So by AAA, these two triangles are similar triangles. Now let's write two sets of proportions, solve them so that we get the value for OT and PT. Let me start with the first here, which is OR by PR. OR by PR is equal to RP, which is nothing but the same as PR divided by RT. Let's plug in the values that we have. OR, we computed it to be equal to a 5. PR is equal to 12. PR is again equal to 12. So the only variable that's missing is RT. Finding out RT is very straightforward. RT is equal to, cross multiply this, 12 into 12, which is 144 divided by 5, which is equal to 28.8. So RT equals 28.8. We already computed OR to be equal to a 5. So the measure of OT is nothing but OR plus RT, which is equal to 5 plus 28.8, which is equal to 33.8. So one measure we have already found out. The second measure I'm going to be finding out by establishing one more set of proportions. The first one that I'm going to be writing is the same, OR divided by PR. So pick these two. I'm going to be picking basically OP and PT. This is equal to OP divided by PT. Let's plug in the values that we have. This is OP, I'm sorry. This is I'll write it again. OP divided by PT. What is the measure of OR? OR is equal to 5. PR is equal to 12. What is the measure of OP? OP is equal to 13. We need to find out PT. Cross multiply. PT is equal to 12 into 13, which is equal to 156 divided by 5. 156 divided by 5 is equal to 31.2. So you found out PT, we found out OT. If you want, you could have found out this PT a little differently also. We have found out in this triangle OPT, which is a right triangle. Now the hypotenuse measures 33.8. We know the measure of OP is equal to 13. So you could have used Pythagoras theorem and computed the value of PT. The calculation there might be more difficult than going about it this way. So I prefer the similar triangle route to calculations than the Pythagoras way of finding out the calculations. Quickly summarize all this discussion in a printed form. Let's start by establishing how these two triangles are similar triangles. I'm going to be starting with this. In triangle PRO and PRT, these two angles are equal to 90 degrees. I'm going to assign the value of angle POR to be equal to theta. If this angle is equal to theta, OPR, this is going to be the balance, which is 90 minus theta. Now, if this is 90 minus theta, because OPT is equal to 90 degrees, this value, this bit, triangle, angle TPR will be equal to theta. So in triangle PRT, we know two measures are theta and 90. So angle PTR will be equal to 90 minus theta. So we have 90 minus theta, 90 minus theta, 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 and 90 degrees. By AAA, we have established that these two triangles are similar. Let's pick out two sets of proportions. The first set of proportion is basically OR by PR is equal to RP by RT. Let's pick the values. OR is equal to 5, PR is equal to 12, OP is equal to 13. So let's plug in all of those values. OR is equal to 5 divided by PR, which is equal to 12. RP is also the same as PR, which is 12 divided by RT. Cross multiply to find the value of RT, which is equal to 28.8. If RT is equal to 28.8 and OR is equal to 5, OT is equal to 33.8. So move on to the second set of similarity. Second set of similarity is basically OR by PR is equal to OP by PT. Plug in the values. OP is equal to 13. This is equal to 12. This value is equal to 5. So OR 5 divided by PR is equal to 12 is equal to OP, which is 13, divided by PT. PT is equal to 13 into 12 by 5, 156 by 5, which is equal to 31.2.
Supercharge your math quotient. Sign up today for online CBSE math classes at online.maxtute.com. I'll repeat it, it's online.maxtute.com. And before you leave, check out the related videos and remember to subscribe to this channel.